Okay, we're going to do the 2015 AMC 12B problem 17. An unfair coin lands on heads with a probability of 1/4. When tossed n times, the probability of exactly 2 heads is the same as the probability of exactly 3 heads. What is the value of n? Now, those of you who are in statistics or have taken statistics might recognize this situation as a binomial distribution where we have n Bernoulli trials with a success probability of 1/4. But if you haven't taken statistics, don't worry, we can still go through this problem. To do this, we need to figure out the probability of 2 heads and the probability of 3 heads when we toss this coin n times. So let's think about that. The probability of 2 heads. Well, in order to do this, first of all, we know that the probability of heads is 1/4. So when we do this, we need 2 heads, which means that we need to get 1/4 twice. The probability of getting heads twice is 1/4 for the first head times 1/4 for the second head, which gives us 1/4 squared. If we want exactly 2 heads, then that means we need the rest of the flips to end up tails. If we have 2 heads, then there are n minus 2 tails, and the probability of tails is just 3/4 because 1/4 is heads. So you have 3/4 to the n minus 2. So now we have this, and then the last thing we need to do, this is only the probability of getting 2 heads in one specific way. So for example, say I flip heads the first time and heads the second time, and then tails the rest of the time. The probability of that event is this. But I could also get heads the first time, and then tails the second time, heads the third time, and tails the rest of the times. So then we have 2 of these probabilities. And we have to figure out how many different ways there are for us to get exactly 2 heads, and then multiply that by this probability, so that we get the probability of getting 2 heads in any way possible. So we need the number of ways that you can choose 2 of those tosses to be heads out of n tosses, which we write as n choose 2. Now we can calculate this a little bit. N choose 2 is n factorial divided by 2 factorial times n minus 2 factorial. And then we have 1/4 squared times 3/4 to the n minus 2. Now we need the probability of getting exactly 3 heads. So the probability that we get 3 heads is going to be the same form, but all of the 2's being switched to 3's. So now we have to choose 3 tosses to get heads, and then 1/4 to the third for 3 heads, and 3/4 to the n minus 3 for the rest being tails. And again, we can expand this out a little bit. N factorial over 3 factorial times n minus 3 factorial times 1/4 cubed times 3/4 to the n minus 3. And now they say the probability of exactly 2 heads is the same as the probability of exactly 3 heads. And that means that this probability and this probability are equal. So these 2 expressions have to be equal as well. We can use that here by setting these 2 parts equal to each other. That gives us n factorial over 2 factorial times n minus 2 factorial times 1/4 squared times 3/4 to the n minus 2 equals n factorial over 3 factorial n minus 3 factorial times 1/4 cubed times 3/4 to the n minus 3. Now we need to figure out how to cancel stuff so that this is simpler to deal with. Because these are all multiplied, we see we have n factorial and n factorial on the top. We can cancel those out. Now looking at the rest of these factors. 1/4 cubed and 1/4 squared are both here. If we divide both sides by 1/4 squared, this will go away, and this 1/4 cubed will be reduced to just a 1/4. Same thing with this 3/4 part. If we divide by 3/4 to the n minus 3, this part will go away. 3/4 to the n minus 2 is the same as 3/4 times 3/4 to the n minus 3. Because this is to the first power, if we add these two exponents together, we get n minus 2. So this 3/4 to the n minus 2, if we divide by 3/4 to the n minus 3, is just going to be our 3/4. Now we have to look at the factors on the bottom. And to do that, we can use the fact that k factorial is equal to k times k minus 1 factorial. If you think about multiplying k times k minus 1 times k minus 2 all the way down to 1, if we take out the first k, then what we're left with is k minus 1 times k minus 2 times k minus 3 and so on down to 1, which is just k minus 1 factorial. So when we look at our factorial here, n minus 2 factorial is just n minus 2 times n minus 3 factorial. So if we multiply both sides by n minus 3 factorial, this part will cancel, and our n minus 2 factorial is just going to turn into n minus 2. So we can take that factorial off. We can do the same thing with 3 factorial and 2 factorial, because 3 factorial is 3 times 2 factorial. And when we multiply by 2 factorial on both sides, this will go away. This will just become a 3. And now we can rewrite this equation with all these cancels and solve for n. So on this side, this part's canceled, this part's canceled. We have 1 over n minus 2, and then we have a 3/4. And this is equal to, on the other side, we have 1/3 times 1/4. Now we need to solve for n. First of all, we see that we still have a factor of 4 on the bottom in both cases. We can cancel those out. And then what we have left, we can multiply by n minus 2 to get it onto the top, and then we'll multiply by 3 to move it to the other side. So on this side, n minus 2 is on the other side, so 3 times 3 is 9, and that is equal to n minus 2, and then that just gives us n equals 11. So this is our answer.